So now that we saw an example with our coin problem, let's give the general definition for ordinary generating functions. So suppose you have a sequence, an, so you can think of it as you have some sequence, a0, a1, a2, and so on. So you have some sequence. Then the ordinary generating function of this sequence is this power series over here. It's just essentially the sequence, but with these powers of x. And so the idea is that the sequence terms become coefficients of powers of x. So the coefficient of x to the power 0 is a0, the coefficient of x to the power of 1 is a1, of x squared or to the power of 2 is a2, and so on. So a generating function is a way to sort of package an entire sequence into one formal power series, right? So instead of dealing with a whole sequence, you sort of deal with one expression here, with one power series. And the reason this is useful is that we can often do algebra with the generating functions, and then from the algebra we can learn information about the original sequence. So for example, we may be able to find a closed formula, or a recurrence, or some useful identity for the coefficients. And this is exactly what happened in our coin exchange problem. The coefficients counted the number of ways to make each amount of money, and we were able to use the power series to find recursions that then helped us compute the answer to the question we were interested in. So let's look at the most basic examples. So first, if you consider the sequence just of ones, so a0 is equal to 1, a2 is equal to 1, a3 is equal to 1, all the ai's are equal to 1, then you have this here. So this is the power series you get 1 plus x squared plus x cubed and so on. And we already saw that you can write this, so just using the geometric series identity, you can write this as 1 over 1 minus x, right? More generally, if you have a geometric sequence, so if an is the sequence r to the power n, so a0 is r to the 0, which is equal to 1, then you have r squared, and so on. Then the generating function for this, again using the geometric series identity, because you can write it like this, you get this expression here. And so these are simple examples, but they are important because many generating functions are actually built from the geometric sequence.